Okay, this is help with the Name That Charge Interactive. This one does not keep track of your score the same way that some of the other concept builders do. So at the beginning, you will have to type in your name. You will be taking a screenshot at the end with your name showing that you have completed it. Okay, so first thing you have to do is watch the little video. So we have 2 neutral metal cans. So it's important to read this, mounted on insulating stands, and they are touching. A negatively charged balloon is going to be brought near one of the cans. The cans are separated and the balloon is moved away. So it's important to watch what happens. Each situation is different. Now make sure you look at which object it's asking you about. It could be asking you about the balloon. It could be asking you about either of the cans. In this case, it's asking about can A. It's asking about this can. So if we think about what's going to happen here, as the balloon is brought forward, these are conductors. So the negative charges are going to want to move away from this balloon. So those negative charges, the electrons in other words, have moved to can A, so that can A becomes negative and can B would be positively charged. When you separate them, they're stuck. So the excess electrons are here and a lack of electrons are here. So the charge on can A should be negative, and then notice it asked me about the charge on can B. It should be positive. So let's go ahead and check that. Okay, I'll show you a couple other examples if you need them. So in this case, a neutral metal can is mounted on a foam stand. A positively charged balloon is brought near, and the can is touched on the opposite side. So that's what happens. Notice the finger does move back before the balloon. That is important. At the end it says, when the process is over, what is the charge on the balloon? Well, the balloon was positively charged and you never had any electrons leave it or come onto it. It's an insulator. They're not going to jump or anything like that. So the balloon is going to remain positively charged. The can, as we watch this happen, what's going to happen here is electrons are going to want to get close to this positively charged balloon. So electrons are going to go up through the ground, through your finger, onto the can. And so, again, here comes the electrons. They're onto the can. Now when you pull your finger away, they're trapped. So that is going to leave that negatively charged. This is called charging by induction. Anytime you charge by induction, the objects will get an opposite charge. Okay, perhaps we'll look at just one more example. Okay, so you can see this example is fairly similar to the one that we just did. The balloon is positive and it is going to remain positive. None of the charges were taken away from the balloon in any way. When the finger comes over to this sphere, electrons are going to go up the arm again because they want to get close to this. So electrons are going to come up. And then once you take your hand away, those electrons are trapped onto the sphere, leaving it negative. Okay. One last example, very similar to the other ones. The foam board in this case is negatively charged. It's an insulator. Nothing is actually touching it to remove that excess charge in any way, so that is going to remain negative. Now, the metal plate, when you put your finger here, electrons are going to want to get away from this negative bunch of electrons, so electrons are actually going to leave the pi 10 in this case, leaving it positive. Okay, hopefully that's enough examples to help you.